Hi, in this session, we will be talking about 7 segment displays. And in the next session, we will use this 7 segment display into our project. So this is pretty basics that what is 7 segment displays, how they work, and how to drive them in VHDL, etc. So this is a very simple package of 7 segment display. This is well-defined package of LEDs and they are placed in such a way that they can show numbers or some characters. And if you count these LEDs, they are 8 in total. Out of this, 7 LEDs are used for displaying numbers or digits and one is reserved for DP or decimal point. Now each LED here is driven by a separate pin. So you can see 8 pins here. So they are labeled as pin A, pin B, pin C, pin D, pin E, pin F, pin G, and pin DP. These are your 7 segment display pins. You will also have one extra pin in your display, and that is common pin. And it is connected to the second terminal of all the LEDs. So this can be either common anode of all the LEDs or common cathode of all the LEDs. And that's define your type of 7 segment display. Means if it is common anode display, then this common pin will be anode of all the LEDs. And if this common pin is cathode of all the LEDs, then it will be common cathode type of display. Now you can see in this 7 segment display package that each LED label is placed here with their name. So this is LED A, this is LED B, this is LED C, this is LED D, this is LED E, this is LED F, and this is LED G. And last, this is decimal LED. So these are total 8 LEDs including decimal point. And you can control each LED individually by using your 7 segment pins. And all the LEDs having one common terminal. This can be either anode terminal if you have common anode type 7 segment display, or it can be common cathode terminal if you have common cathode type 7 segment display. So suppose you have common anode type of display, which is generally used. So we will design our 7 segment decoder for this common anode type of display. Although the concept is same for common cathode type of display as well. The only difference is that the pins are just inverted. So you can simply use a NOT gate to invert your decoder output so that you can switch between common anode or common cathode type of display. Now, by default, our all the LEDs should off because we are not displaying anything. So in this case, you will apply logical 1 to all the pins of your 7 segment display. Why? Because you are using common anode type display and its common pin is already connected to this plus VCC. And if you apply the same voltage to the another terminal, means these 7 segment pins, then current will not flow through these LEDs. So they are off, right? So when they will glow? They will glow when you will apply logical 0 to 7 segment pins. So these second terminal will 0 or grounded, and then current will flow through these LEDs and your LED will turn on, right? For example, consider this first LED or segment A. So when you apply logical 0 to this terminal, then the current will flow through this LED and it will glow, right? So this is basic concept. Now by using this concept, if we wanted to see number 3 on this 7 segment display, then we need to make sure that these specific LEDs should on and rest LEDs should off. So you can see that each segment is marked with their name here. So for number 3, we should turn on these LEDs like LED A, LED B, LED C, LED D, and LED G. And LED E and F are turned off at this time. So you can see on the left side that corresponding segments are logical 0 so that they can glow, and segment E and F are logical 1. Okay, so this is basic concept, how 7 segment display works and how we decide which LED should on and which LED should off to display any specific number. Now we will create this table for each digit, and this will tell that which segment should glow and which segment should not glow to display any specific number. So let's create this table, and this is very important because we will be using this table to design our 7 segment decoder in VHDL. So we will start from number 0. So for 0, all the LEDs are on except this segment G. Means for common anode type display, we will set logical 0 to all the segments of this package except segment G, right? So our output will be 0, 0, 0, 0, 0, 0, 1, 1. Last LED is our decimal point. Okay, so don't get confused. So let me brief this. We have this LED as an output port, and this is STD logic vector signal, and this will have 8 elements inside it. So it has the range from 7 down to 0. So segment A is our LED 7, segment B is our LED 6, segment C is our LED 5, segment D is our LED 4, segment E is our LED 3, segment F is our LED 2, segment G is our LED 1, and segment DP is our LED 0. So that's how we will design this. Now for number 1, segment B and segment C are on and rest all the segments are off. So our output will be 1, 0, 0, 1, 1, 1, 1, 1. Next for number 2, segment C and segment F are off and rest of the LEDs are on. So our output will be 0, 0, 1, 0, 0, 1, 0, 1. Next for number 3, segment E and segment F are off and rest of the LEDs are on. So our output will be 0, 0, 0, 0, 1, 1, 0, 1. Next for number 4, our output will be 1, 0, 0, 1, 1, 0, 0, 1. So I hope you understand this and you can complete it for rest of the numbers. So I am not repeating it again for all the numbers. So quickly see for this number 8. For this, all the segments are turned on. So our output will be 0, 0, 0, 0, 0, 0, 0, 1. And for number 9, only segment E is off. Rest all the LEDs are on. So our output will be 0, 0, 0, 0, 1, 0, 0, 1. Now remember that this is the table for common anode type of 7-segment display, which glows the LED when you set logical 0 at the output, right? If you are using common cathode type display, so you need to give logical 1 to glow the specific LED. Means that will be invert of this table. Means replace logical 0 with logical 1 and replace logical 1 with logical 0, or simply use NOT gate for this inversion. We will be using common cathode type of 7-segment display in our next project. So I will show you that table as well. Okay, so that was a brief about 7-segment display. And now we know that what are these 7-segment displays. We learned common anode type of 7-segment display and common cathode type of display. We learned how they works, and we created a matrix table for 7-segment decoder output for common anode type of display. So in the next session, we will be using this 7-segment decoder knowledge to design a project, and we will implement it on a FPGA board as well. We will also discuss 7-segment multiplexing technique, which is very important when you are working with more than one display. So stay tuned for the updates. If you did not subscribe till now, then please do subscribe to learn and grow community for regular updates. If this video is informative, then please like this video, comment on video, and don't forget to share. Thank you for watching.